Hi, I'm Steve Yee, Director of Product Management for SQL Azure. Today, we'll run through some basic architectural considerations that can help you establish best practices and optimize your SQL Azure databases. In this video, we'll start out by talking about the benefits of SQL Azure, and then we'll introduce several considerations for optimizing your SQL Azure databases, including optimization for security, performance, and cost, partitioning and sharding, indexing, and latency. We'll also demonstrate how to use T-SQL code to create indexes and test latency to SQL Azure using SQL Server Management Studio, or SSMS. Finally, we'll review what we've learned and point you to some additional resources to help you get started. When you move your data to SQL Azure, you can free up time and reduce risks associated with managing and maintaining your own in-house database servers. Once in SQL Azure, your database is highly available, reliable, and scalable, and can be accessed from anywhere via the internet. SQL Azure is also highly flexible and allows you to pay as you grow, eliminating the need for upfront capital expenditures. Now, let's take a closer look at how to optimize your SQL Azure databases. The most important thing to remember when moving to SQL Azure is that most standard database optimization techniques apply, and all of the standard techniques that DBAs are accustomed to performing will remain familiar in SQL Azure. But in SQL Azure, all of the challenges that come along with managing database hardware are eliminated, making it easier for DBAs to achieve database scalability, uptime, and performance. Sharding is an application pattern for improving the scalability and throughput of large-scale data solutions. To shard an application is the process of breaking an application's logical database into smaller chunks of data and distributing the chunks of data across multiple physical databases to achieve application scalability. Each physical database in this architecture is what is referred to as a shard. Some good application database candidates for sharding include application status updates, content generation, and report or statement generation. You can shard by various categories based on the results you wish to achieve. Some examples include time or calendar units, business units, users or entities, or geography. Establishing and maintaining best practices regarding table indexes can improve performance. Some guidelines include keep the indexes unique and keep indexes small, using as few columns as possible. And avoid placing the clustered index for a table on a column that is of the unique identifier data type. Otherwise, on insert, the new GUID will have to be placed in the correct sort order in the table, as this will greatly reduce performance. Also note that SQL Azure requires the use of clustered indexes. If you're connecting to SQL Azure from an on-premises or hosted application, as opposed to an application running on Windows Azure, you'll also want to architect for reduced network latency. It's important to remember that opening a connection to a database can take time, and when an application is performing many operations on a database, it's faster to open a single connection and perform multiple operations than it is to open and close a separate connection for each operation. One way of optimizing for this is to use batch data calls, which requires that the server make all of the service calls in a certain order and sends a single response to increase efficiency. You can also use store procedures, which are supported by SQL Azure, to improve performance of queries and increase security. So let's walk through a couple of examples on how to improve database efficiency using SQL Azure. We'll start by logging into the Windows Azure Developer Portal and navigate to a database we have already created. If you haven't created a SQL Azure database yet, go to windows.azure.com and create one now. Select the desired database and click the Manage button. Enter the password for your SQL Azure database and click Connect. Once logged into the database, click New Query and we can type out our T-SQL command to create a simple table. SQL Azure requires that tables are created with a clustered index. In addition to this requirement, clustered indexes also increase performance on queries that return a range of values. Also, for queries that contain group by or order by clauses, a clustered index will increase overall efficiency. If we try to run an insert on the table, we see that it throws an error. So we'll create a clustered index and execute the same insert statement. Now we can easily insert information into our table. When deciding what columns to include in your clustered index, make sure to understand all of your potential queries and include the table columns that will deliver the best performance. Besides using a clustered index to optimize query and insert statements, we can also use SQL Server Management Studio, or SSMS, to test for latency. We can use SQL Server Management Studio to test the network latency for each data center in order to determine the best storage location for our database. Imagine you have two synchronized SQL Azure databases, one set up in North Europe and the other in Southeast Asia. You now have a new set of users who will be consuming data in Australia, and you need to decide which SQL Azure database to consume data from. I'll be using two SQL Azure databases called expenses, which we created for earlier demos, one located in North Europe and the other located in Southeast Asia. I'll enter the login credentials to connect to the North Europe database. I select New Query. Next, on the File menu, click on Query and select Include Client Statistics. I'm going to type out a simple query and hit Execute. Click on the client statistics and you can see that the window contains the total time taken to execute the query as well as the time taken for the data to travel across the network. Now I will connect SSMS to the Southeast Asia database and repeat the same steps as before. I run a query on the expenses database and check the client statistics. As you can see, database performance is very fast in both data centers, but overall response time can be affected by data transfer over the wire. In this example, based on my current location, the network latency from the Southeast Asia data center is lower than the North Europe data center, so we should choose Southeast Asia as our primary data source. Please keep in mind that network latency is not static and may vary based on various factors. In this video, we talked about the benefits of SQL Azure, and then we introduced several considerations for optimizing your SQL Azure databases, including optimization for security, performance, and cost, partitioning and sharding, indexing, and then also addressing network latency. We also demonstrated how to use T-SQL code to create indexes and test latency to SQL Azure using SQL Server Management Studio. Please visit SQLazure.com for all the latest information and additional resources. Thanks!